So hello everyone. Welcome to today's meetup. It's impressive that we have over 1,000 RSVPs to that event from different channels, and it's Sunday evening, and people are still joining in. It's pretty impressive to me. And I would like to also thank Daliana for the putting together the event. I'm going to introduce her a little later. Before that, I will just mention about Magnimind. So my name is Murat. I'm Murat Badey. I'm a co-founder and CEO of Magnimind Academy. I'm also a Stanford scientist. I'm a co-founder at SmartLens biotech company. So at Magnimind Academy, we actually started with meetup groups, and we've been organizing over 100 events last 1 year. And we have groups in 6 different places with over 800 members. We really enjoy to have all these free lectures, webinars, workshops, and we have also free boot camps, mini boot camps on data science. And I also have to mention that today's event, almost our meetups are broadcasted through 6 different platforms, including YouTube, Facebook, and several others. And if you are listening from other channels, you may subscribe our meetup groups. You may subscribe YouTube channel to watch the records later. You can also join our website through the website, our email list. And I will with email list. So we are actually located at Bay Area, San Francisco Bay Area, but since COVID, we've been doing our events through the online through the Zoom, and our main event is located at actually our main event is happening in the Zoom webinar. So I will mention about our upcoming free mini bootcamps. So it is gonna be in August. We have a mini bootcamp in Python, and we will have in machine learning. So 2 different mini bootcamps. So this bootcamps will be around 10 to 15 hours in 1 month long. We will have teaching assistants, and we will have problem solving sessions, as well as we have a Slack channel support specifically for bootcamp registers. So this time we're gonna have more emphasis on those mini bootcamps. Hope that during COVID time, it will ease people's life and it will get up on the schedule of learning data science. So also, I will have to mention about our one of the key product is 101 mentorship, project-based mentorship bootcamp, which I will share a screen and talk about it a little bit because many people is asking about it. So 101 mentorship bootcamp has several components. So what we do, we are now accepting our next batches for September. And we do several interviews and selection process for the bootcamp. And we have actually limited space that we can give that bootcamp. So what we have several learning modules, NLP, ML, distributed machine learning, and deep learning modules, where we learn these models through projects. And we also assign people a real project during that bootcamp. So we have 3 main modules. You will learn 3 different core modules in data science. And then we also give practice interviews with people from industry. And we bring resume coaching. And we also bring technical coaching, including resume coaching. We have also speakers from industry inside. They give you all the aspects of how data science working in their companies, what are they doing. So each person is giving a really different perspective on their workplace. We're also connecting our students to the recruiters, to connecting our students to recruiters. So, and after bootcamp finishes with people who have interests, we are continuing providing them internship with different affiliated companies. So this is our main bootcamp is 7 weeks long, and we are hoping that we give everyone as a complete aspect of data science and during that short time. So today I will introduce you Daliana, and she's gonna talk about 5 things only experienced data scientists know. She has an amazing background. She has a mathematics degree, college in China, and then she got her master's in statistics in UC And she's been actually working a lot in A/B testing team before she just joining the Amazon. She's currently working in AWS, and she is developing different algorithms in AWS, especially on computer vision, event detection projects, and sport analytics. And she has patent on A/B testing, and I'm actually quite interested to hear her thoughts and opinions about what data scientists should know, how they should be prepared for their career. Thank you.
Thank you for the introduction. Let me share my screen. Maybe I can stop the video first. All right, are you able to see my screen? And is my audio okay?
Yes, it's pretty good.
Okay, awesome. Great. First, thanks everybody for joining me in this presentation today. I know it's Sunday, and if you're in California, it's pretty nice outside. So I have prepared a lot of content. I hope it will be worth your time. So during the introduction, you already know my background. So I'm from China originally. I studied applied mathematics, and then I went to UC Irvine to study statistics because I want to learn something more applicable. I want to be able to solve problems. And then I started my first job in LA. I was working as a business intelligence data analyst. So what I did was basically I was the company's first data analyst. It's a small, medium-sized company, and then they have a lot of untapped area they want somebody to look at. So that was my first job. I had a lot of freedom to use different type of method I learned in school, and I also learn what actually data science looks like in real world. A lot of things is unstructured, the problem is ambiguous. But then I wanted to learn on the team where there are more scientists, someone can mentor me. And then I got this job in Amazon. So I started as a business intelligence engineer. At that time, it was a mix of report generation, engineering, and also part of my job was statistician. I build models and do analysis on A/B testing. So at that time, there wasn't the concept of data scientist yet. And then later on, because I have already worked on models and then do statistical testing. So those are qualified for a data scientist role. And when Amazon started this data science job family, I became a data scientist. So I had a few years experience work on the team that built A/B testing system for the entire Amazon retail side. And then I got more interested in machine learning and AI. So I moved from Seattle to San Francisco. I started in AWS. I'm on the team. We work with AWS external customers to help them build machine learning models to accelerate their business. We work with customers from different industries, so it's very exciting. We get to learn different domain knowledge and then pick the model to solve different problems. So here's my background. And today I'm going to share 5 things only experienced data scientists would know. And then if you stay all the way till the end, I'll have a bonus topic for you guys. So first I want to, before I talk about what is important as a data scientist, how to grow, or get a job, I think it's important to understand what are the type of data scientists. And if you just hear about what I talk about my background, every role, my title is data related, data analyst, data scientist, but they are slightly different. And it's very important to understand different type of data scientist before you apply, because that's important when you want to pick and choose what to study. And then I will talk about how to get promoted in a company. And the third thing I think is the very important thing I would like to share today is I see a big gap between what you learn in school and what you do at work. And I would like to share all my experiences so you have the right expectation when you find a job. And the fourth one is, what is the most important skill as a data scientist? Is it your technical skill? Is it communication skill? What makes a great data scientist? And the fifth one is, I will talk about how to prepare interviews and transition your career. And please know that I wouldn't tap into a lot of technical details. It's more about the strategies. How do you where to find those materials? What are the important things? So let's start with the 3 types of data scientists. So the first one, data scientist is a very broad term, and then there can be a lot of things under this umbrella. So if you have looked for jobs, for example, on Facebook or Twitter, those jobs are called data scientists, but they mainly work on product analytics. What it means is they do a lot of A/B testing. So they use a lot of statistical testing skills, and they also have different type of metrics: how long you stay on a website, how many things have you purchased, and how do you use different type of metrics to make decisions. And you will work very closely with product managers, and you will generate reports, and then in order to retrieve data, a very important skill is SQL. So like I said, data scientists and data scientists can be very different. I have seen a data scientist who use very little R or Python, but they're so good at SQL, they can generate a report, and maybe that's enough for the specific role. And then I have seen other data scientists don't know SQL, but they can join tables in R or Python. So for those type of roles, it really depends. But I would say if you are interested in product analytics, SQL is a very important skill, and then R or Python will be a plus. Or sometimes you probably will have to use some Python if you want to automate some reports or do data visualization. And then to prepare those type of interviews, for example, I'll just use Facebook as example because I had an interview with them. They would, some of my friends recommended me to read a book called like How to Crack the Product Manager Interview. So you actually need to have a type of structure when the interviewer asks you, how do you improve a product? How do you get more engagement? So knowing statistical testing is not enough. You have to be able to tie that to a product sense. And another thing that's important for this type of data science is you need to know some probability, like Bayesian, conditional probability, because those are things that are closely related to statistical testing. And then if you are owning statistical testing from the beginning, you also need to know a sample survey, how to design experiment. Because in the real life, there will never be a perfect sample. How do you make the trade-off? How do you find a proxy? So there are a lot of information there. And if you want to learn, if you have never learned A/B testing before, there's a free course. I think if you just like, it's created by Google. You just Google like A/B testing course, Google, you will find this free course. And I watched the course before I had an interview with Amazon. So this is a product analytics route. And then your day-to-day would be, you would analyze some metrics, and you might sit in the room with product managers. You can influence a lot of decisions. And sometimes this type of job can be very fast-paced, because if the business needs some metrics, you might need to be able to quickly get the metrics or do some analysis, do some deep dive using SQL or Python. So that's why during the interview, it's very important for them to see you are able to join some tables very, very quickly. And then if you work for a large company, again, I'm going to use the example of Facebook. You might not need to use machine learning. So you probably will need to understand it, because you might work with research scientists or machine learning engineers on some type of product, because there are a lot of say ads targeting will be related to machine learning, but you don't need to do that on your own. So I know a lot of data scientists are interested in machine learning or AI. So if you're very interested in that, then start with product analytics. You might not have a lot of opportunity to use that type of data science muscle. And the second one is machine learning. So machine learning also has a different type of data scientist. So sometimes you see the role is called data scientist, but it requires PhD, and also mention very specific algorithm. They want you to be familiar with that. So those type of roles are actually more like a machine learning researcher or machine learning engineer. And there's another type of machine learning role. A lot of people want to say, oh, I don't have a PhD, can I, or I don't have a master, can I still do machine learning? The answer is yes. As machine learning product or like even deep learning models become more and more mature, a lot of companies just want you to be able to solve a problem. So this type of data scientist is machine learning practitioner. So you don't really have to develop the model. The most important thing is you understand how to collect data, how to select the right model to solve this problem, and evaluate the model. So as long as you find a model to solve the problem, it's okay if you're not a researcher. So if you are interested in this type of becoming this type of data scientist, of course, you will need to learn machine learning. You need to learn Python. And like I said, those type of data science can be very different. And because I have an interesting background, I've been working both product analytics and machine learning. So I know A/B testing, and also I know machine learning, but I talked to some of my current coworkers, for example. Some of them never studied A/B testing, or didn't even use SQL, or don't know a lot about probability theory. Doesn't mean they're not great data scientists. No, it's just different type of roles have different type of requirements. You don't have to be everything, and the company is usually not look for everything. So you don't need to feel anxious if you don't know something. Just need to pick a route that interests you, or most fit for your background. And then again, so there's a difference between practitioner and engineer. And if you are a practitioner, you might not need to productionize a machine learning model, but it's good to still learn something about algorithms, how to connect your model to production. And if you're machine learning engineer, of course, a lot of people do work as a machine learning engineer, come from a computer science background, and then they have to be able to scale up the model so it can be in production. A lot of them, their job duties are very similar to software developer. They will on call, because if your algorithm, for example, is customer facing, right? You're recommending, say, like images, or doing some type of ranking for search. And if your algorithm doesn't work, you will need to be able to fix it. And the third one is a very common one. It's a generalist. So it's kind of similar to my very first job, because it's a smaller company, right? So your data scientist role is not very specialized. And I used some A/B testing, and I also used some statistical modeling. I did something like regression models. I built time series models. So for this type of role, you need to have a broad set of skills, but you don't have to be very deep in any of the skills. But of course, it would be good if you have some type of specialty. But for this type of skills, what they're looking for is not like you have to be an expert. They're looking for someone to solve a problem fast. So the next one is, we talk about the 3 type of data scientists. Excuse me, take a sip of water. I found the 3 actual job postings. Let's take a look at some examples so you can remember what I talked about. So the first one, just give you a few seconds to take a look. Let me see if you can type in Q&A. I guess I can see it. What type of data scientist do you think this one is? Master degree in quantitative discipline, data analysis field experience, Python, SQL. What type of data scientist do you think this one is? Machine learning. Yeah, some people say this is machine learning, but this one didn't really specific mention machine learning, right? Like you can study statistics, you can do operational research. It says pretty generic data and analysis related field, and then it mentioned the SQL and MATLAB. And then another thing is, every employer, they have something they prefer. Everybody prefer PhD and a lot of years experience, but you don't need to be intimidated by the preferred qualification. It definitely will make you a better candidate, but I would say the most important thing are the minimal qualifications. And especially when you try to understand what will be the day-to-day like, look at the minimal qualification first. So this one, the answer is, this is more like a general, data scientist generalist. Because if you want to see, you can see here, solve, where is it? I took some notes. I think you can find, you wanted to develop analytical framework. So this is kind of vague, to monitor business and product performance. So this is a little bit like metrics development, right? And then here, analyze experiment. So here definitely there's some A/B testing in there, and translate data insights into decisions, and then metrics that measure that helps. Oh, sorry, did I go to a different slide? Oh, I'm so sorry. I didn't notice. I just clicked. Sorry, the first one is, you're right, is the data science generalist. So here's what I want to show you. If you can see my cursor. Sorry, I didn't realize I went to the next slide. So this is very important. Select the right statistical tools given a data analysis problem. So this means it's okay that you don't, it's not very specific on what tools you have to know, but you need to know a broad set of tools. So when you have a problem, you will select the right one to solve it. So this is usually Signal. This is a generic tool. And then they want you to know regression or other type of models, or the most important thing is you can learn very fast on the job. So when I started my job, when I learned in school, my program was focusing a lot on biology and biostatistics. But my work is, I was supporting marketing. So I have to learn some regression applications in the marketing field. And then when my first manager tried to hire me, she didn't ask me anything about marketing because she was looking for someone has a foundational knowledge, and then she wasn't looking for something I didn't know. So it's okay, like you don't know everything, but you need to understand the basic knowledge so you can learn on the job very quickly. And the second one, we looked at a little bit what type of data science. Yeah, someone said it's product analytics, right? Because whenever you see something about decision making or experiments, sometimes they don't mention A/B testing explicitly, but if you see experiments, launch decisions, product performance, is definitely related to A/B testing. And then the metrics, you might need to build some dashboard using Python or R, those experience statistics, it didn't really say machine learning. So if you don't know machine learning, you're totally fine in this role, but you need to be very strong in experiment design. So basically that's all the keywords I mentioned in the previous slides. So the next one is a Salesforce data science role. This one is really large, so I just take a screenshot. So yeah, previously we mentioned generalist and the product analyst. So this one, you probably have guessed that this one is a machine learning data scientist. Production level code, right? So if you look into more, maybe this one can be a mix of a data science practitioner, or maybe even more like a machine learning engineer. And they want you to have hands-on experience focusing on machine learning information retrieval. So previously, those data science role, you don't see them mention skills in Java, Python, or even Scala, but right, this one mentioned that object-oriented design. So this one means you don't just need to build the machine learning model. They would expect you to work with engineers to productionize that. So if you have background in some type of engineering, if you learn some machine learning, maybe that's a good fit for you. But if your background is more like statistical modeling, probability, or pure math, if you haven't learned a lot of programming, you can definitely, I believe anybody can be a data scientist. You can learn programming, right? You can go to boot camp, take online course, but if you need to find a job very quickly, this one might be a little bit difficult for you to learn programming skills really fast, but it's a good fit if you want to transition from machine learning data scientist from a software engineer or any type of other engineering background. Any questions here? I know we are already 30 minutes past. Okay, if we don't have any questions, I'm gonna go to the second point. So how do you grow and get promoted in a company?
So excuse me, there are questions in Q&A. You may maybe look at that later. A lot of people's questions getting lost during the chat. If they ask their questions, the question session, it'd be nice because they put in the chat, it's getting lost. So you may depend. It's up to you. You may go over them later or now.
Yeah. Okay. What type of? So me just take a look. How about I ask those, some of the questions are pretty specific. How about I ask the questions in the very end?
Yeah, it sounds great.
Yeah. And then maybe I think some of the questions might be also answered during my presentation. So yeah, let me just continue on the slides. So if you are if you already hired, how do you grow in a company? When you are hired, of course, as a data scientist, you're very eager to tackle a difficult problem, or you're thinking about create a model that's very fancy. What is the most important thing? How do you find the projects, right? So when you're in a team, you might usually when you're on the data science team, they usually have a different type of projects. And then when you are a beginner on the team, maybe your manager will assign some projects for you. But when you demonstrate the ability that you can finish those projects well, maybe you can also influence your manager to mention what are your interests, what type of projects do you want. So here I have 3 circles. So ideally, you want the project with all 3 of them. And why 3 of them? So I'll start with business impact. So when you just started in a role, maybe the senior people are working on those important projects. Maybe you don't get to work on the project that's most interesting. And is that bad? I wouldn't say that's bad, because if you think about a company, right, they want to have business value. Whenever they decided to invest in a data science project, it's related to their business goals. So even if this project is not very interesting, maybe just want you to build a dashboard. Of course, some people are interested in building a dashboard, but if you're more interested in doing some analysis or modeling, maybe that's not the most interesting thing for you. But this thing has very important business impact. It would directly help product managers make decisions. So I would say also just don't feel so frustrated. Also treat this type of jobs as something that's important, because maybe a lot of things hasn't been automated, and if there's something that's not exciting, maybe you can look at the data and then drive some insight to your manager. So instead of just creating some metrics or report, you can build some type of data science models on the side to help your manager make decisions. So when you just started a job, the project that have business impact is very important. And doesn't mean those projects are bad if it's not something you were interested in, or if it's like mathematically easy. Because if you think about how they evaluate you in the end, the business want to solve the problem, right? They don't care whether you are using a very fancy model or you're solving it with a simple model. If this help the business make money or save cost, that's a good solution. So focus on the business impact first. And then once you proved to your team, your manager, that you have the ability to have to help the business, to add value to your team, and then you're thinking about getting a promotion to the next level. And then because you're still a data scientist, you need to think about your technical depth. Usually they will promote the promotion for the next level will require the data scientist to be able to solve a more complex problem independently. And there's a difference between being on a big team or big company or small company. If you're on a smaller company, maybe the role guidelines, how to get promoted, isn't very clearly communicated. Maybe if you are a startup, maybe the startup doesn't even have this type of documentation. So what you need to do is when you think about a promotion, you need to communicate with your manager, have some type of roadmap created. It's better you guys can write those things down. Okay, what do I need to do to go to the next level? You review what are your current kind of weakness, and then to work on those, and then what type of level is expected. So once you have this communication, you know what area you need to study or take more project on that area. And once you have this type of conversation, your manager can also be more conscious in assigning project and will help you promote. So you don't have to have the conversation about promotion when you feel you want a promotion. You can have the conversation maybe 6 months when you're on the job, and then just say something like, it's not like I'm asking for a promotion, just ask your manager, how do I grow to the next level? What do I need to study? Ask for feedback, and don't be discouraged if your manager say, oh, you're not ready. Just ask them to give you some specific guidelines so you can work on those areas. And if you're on the big company, for example, I give Amazon as example, we have role guidelines that is very clearly defined what is expected for each level. So for example, if you are the entry level, you need to be able to finish your project, deliver results. But on the next level, you need to be able to work on a project more independently. And those guidelines, it doesn't require you to have certain specific technical skills. It's more about whether you are able to finish the project, use whatever skills you have, and solve whatever problem you need to solve on your specific team. And the third one is your interest. So once you, whether you are in a small company or a big company, after you talk to a manager, either come out with your own path or review some type of existing role guideline, say you get promoted. And I think now if you have earned the trust of your company and your team, you can start to tell a manager about your interest. Because if you, it's possible, right? The project with business impact and the project also have technical depth are not what you're interested in. For example, you have been working on A/B testing, doing a lot of experiment design. It's very, it could be very complex and it has large business impact, but you're interested in to say build a machine learning model. So here is you can ask your manager whether there are opportunities for you to try those type of models. But still, your interest shouldn't be completely separated from the business impact, because still you work for a company, you don't work for a research organization, right? It just why interest is important, because if you are always work on something that you're not interested in, you're not going to feel fulfilled on the job. And then if you don't feel fulfilled, your performance, you might not perform as well as someone who is very passionate about what they're doing. So I would say when you just start a job, start with business impact and go to technical depth, or those two can be together. And then you can start to work on something you're interested in, but always remember everything should be tied to the goal of your company, the goal of your manager. And then if one example is sometimes you learned a very new model from online, you really want to use this and it's very cool, but it doesn't really help your team solve a problem. So your manager might not really appreciate if you spend a lot of time on that type of project. So here is how you grow on the team and how you get a promotion. The next one, I'm going to talk about what are the most important skills as a data scientist. So like I said before, once you start to work for a company, the complexity of a model is not the most important thing. But of course, it doesn't mean we don't learn new models, new skills, because there are so many new techniques, so many new knowledge about data science, right? It's We are all learning all the time. But it's good if you think about the problem, solving the problems. If you have a toolbox, it's always good to have more tools under your belt. But the most important thing is to solve the problem. And a lot of people go into, especially new data scientists, when they're assigned a problem, they want to use some very complex tools. But if, say, a regression model can solve the problem very quickly, and you can interpret the results, why do you have to use, say, a deep learning model or other type of model that costs a lot of resources? So whatever you do, focus on the problem first. And sometimes in the middle of the projects, and we might get distracted by small technical details. And always think about, what is the project problem you're trying to solve? Is this does this small detail matter, or is there someone else can help you solve the problem? So when I just started, some mistake I made was I was very shy to ask for help. I just feel, oh, if I ask other people to help me figure something out, maybe other people will think I'm stupid. But when you're on the team, it's expected. Nobody knows everything. And if you can figure something out, you need to ask a senior person or ask your manager to help you solve the problem. It doesn't, so if you're working on a project, if you are the major contribution to the project, it doesn't mean you have to solve everything on your own. And it's also important to solve the problem with other people's help and know when to ask for help. Of course, you're going to Google something and then try to figure out on your own. If you can't, getting other people's help and then solve the problem, that still demonstrates your ability of solving a problem. And also always start with a simple method and don't go into the most advanced model too quickly. And the companies, they hire you, especially if you're in an entry-level role, they want you to do a reasonable time, a reasonable job within a certain time, and monetary constraints. They can't afford for you to develop a model that has 100% accuracy taking, I don't know, 5 years. Again, your company needs to be able to move fast. So you need to solve the problem fast. So whenever you're thinking about learning a new skill or taking on the project or thinking about how deep you're going to the problem, always going back to the initial goal of your project. And if you're not clear, always talk to your manager to get clarity, because things change very fast. Sometimes the problem you're trying to solve maybe later on is not become very good anymore. It's not gonna become very important anymore. So the fourth one, I'm going to talk a few points about the difference between school and workplace. So in school, when we have a project, or even when you're doing a boot camp, they already prepare the data source for you and it's validated. Well, if they really want to test you, sometimes they might intentionally put some missing data, but it's still pretty easy to figure out. But in the industry, especially if you're in a company where the data science is supporting a different type area of business, the data is all over the place. And then if you think about, say, you need data from the sales department or from the operation department, sometimes they don't even have the same index for you to join the data together. And a lot of times you need to be the person. Usually they don't really have you don't always, I would say you don't always have a project manager or program manager to help you with those things. So you are the program manager to manage working with different teams to collect the data and then also check data quality. So it's very common that you might spend 50% of your time just to build pipelines and getting data. And why I say data quality is very important, because there are so many unexpected events when other teams collect the data. And what does those data mean? In the beginning, when you just started your career, you might find those process very tedious. But the model is only gonna get as good as your data is. So if your data is crappy, you're not gonna have a good model. And once you have collected all the data and the quality is good, it's actually very easy for you to find a tool and solve the problem. So this is very different from from in school. And if you don't have this expectation, you might feel frustrated or confused. And also, like I said, you might have dependencies on other teams, right? Okay, I'm gonna answer a question here. Sometimes you lose respect from the team when they see you asking or looking for answers. I don't know the context of this. I think this is a previous point I mentioned. You need to ask for help when you need help. I don't think this is the case. I think if you think about this, right, you have a problem, but you don't ask for help and you delay the project or didn't deliver high quality products. But versus you ask for help, you look stupid, but somehow because you asked for help early in the project, you're still able to deliver the product in the end. So I don't think you look stupid. Nobody is perfect, and if your team make you feel stupid, then if this is something common, then you need to consider whether this team culture is good, because a good leader is supposed to make you feel safe when you have concerns or want to ask a question. Of course, you need to ask a question after you do some type of research, or you have a few proposals, how do you solve, and ask your team to help you, give you some suggestions. Never ask a question without doing any research, but you don't need to be afraid of losing respect from other people if they ask a question. So that's a good question. I think this is an important one to address, so that's why I stopped the presentation to do this, but the majority questions, I'll answer them later. Yeah, in short is don't be afraid to look stupid in the beginning, otherwise you look stupid in the end, right? So the next one, I was talking about the second part. So I talk about dependencies on other team. Sometimes your managers, it's different from in school. Your professor has the absolute authority. Your professor is not going to help you solve the problem. But if you work in a company, your manager isn't just the person who assign a task for you. Your manager is there to provide you resources for you. So of course you need to respect your manager, but there are some cases you also need to manage your manager. What do you mean by manage your manager? I'll give you an example. If you need, say, data from the engineering team, but they never collect the data for you because engineering team, they have their own priorities. They don't want to just collect the data for you. And the engineers listen to their manager. So here you need to talk to your manager to see, I need to have this data, but it's not their priority. Can you help me to talk to their manager and prioritize this if this is something really important for me, right? And then your manager talking to their manager is very easy to help the engineers prioritize their task. So collecting data, doing those things, you work with a program manager on your own sometimes, but don't forget to leverage the resource from your manager whenever you feel like you're not supported enough. It's not because other people don't want to listen to you, you're not important or anything. You don't need to feel frustrated. Just those things are sometimes outside our scope. Whenever you feel like you already tried to communicate with them, they don't listen to you, ask your manager to help, and your manager will be very happy to help. And then your manager will also appreciate you ask them to help them, because that is their job. And the next one is in school, we focus on a lot of theory, right? I remember when I was in school, we have to hand derive all the regression, those formulas and all the probabilities, do like statistical testing just by hand. And at work, they might test you that just to see how much you understand it, but you don't do that at work. So the important thing is to know how to find, say, Python package or some other tools to do that. And also, you might do the same type of task if you build some type of model or report. This type of model and report might be used multiple times. So you also, if this is a successful model, your manager might want to make it into some type of data science product and how to scale up. So at work, you don't need to be too concerned about how do you derive a lot of formulas, spend a lot of time on that. Of course, those things are important. Especially it's important if you're a data science, like research scientist or researcher, but most of the time you need to think about how do you finish this project, get things done. So I feel like there's a missing piece in school, that we spend so much time on prove those probability theories, but nobody really tell us how do we scale things up, how do we productionize a model, how do you evaluate the pros and cons. Well, in school you do learn that, but not in the production context. So at work, sometimes maybe you work on a team where your managers they're not data science managers possible, they're product managers, or they are engineering managers. And if you're in that kind of team, solving the problem is even more important. And also, if you pick a model, you need to think, how do you communicate in their language so they can understand what they're doing with your model. When in my first job, again, another mistake I made was I had a presentation with the marketing team, and I started to talk about something like p-value. I just thought everything would know p-value, right? That's what we learned in school. And my manager, she's a science manager, but when I did a dry run with a presentation, the thing she said the most was nobody would understand what you're talking about. So you need to tell those people, tell your audience what's the application of your model, right? What decisions, what are the next steps they can get from your model, instead of just talking about the theories. Another thing is, again, I mentioned a couple of times, the application is the most important thing. When we're in school, if you do a homework or some type of project, if you want to improve the performance to 1 or 2%, you might spend multiple weeks. And if you're familiar with the Netflix prize, a few years ago, I think it's $1 million. They want to award this team $1 million if they improve their algorithm. There was a Kaggle competition. So there was a team did improve their algorithm significantly. However, Netflix didn't launch this algorithm, although it's the best. Why is that? Because Netflix, again, is a company, right? If you think about, there's a very good recommendation algorithm, but whenever you watch Netflix, it has a render 5 seconds. Your audience is gonna lose patience. So there is always a trade-off between like your accuracy, other metric, precision, recall, the performance model versus the engineering cost and the customer experience. So whenever your manager give you a project, discuss with your manager. Sometimes your manager might not even think about the engineering part. So you can also think about it. Discuss with the manager would be a rough level of acceptance? Is it maybe 80% is good enough? So maybe that will be a waste of your company's time if you spend another month to improve that to 85%. Or maybe there are some other cases you really want to have 95% of accuracy. And then at that point, you need to decide maybe you do need to spend longer time on this data science project. So always think about the production and the engineering cost. So sometimes if your model is too complex, maybe it's really hard to go into production. So maybe you sacrifice the performance by 5%, but it's very fast for the engineer to implement it. And then if it doesn't really hurt the business value, and that's fine. So don't fix it on the performance of the model, but of course the higher the better, but there is a sweet spot, and sometimes it's very hard to decide. There is no good answer about how good is good. The answer is always it depends, and depends on how urgent you want in this launch of the product and how much risk your team can take. The next one is how, this one I think is very important. How do you succeed in the projects? Again, in school, we're so used to we just put our head down, work on the projects, and then at the end of the semester, you submit your homework and you're done. And at work, it's not like this. Because in school, your homework, the requirement is very clear. You know what you are supposed to do. But at work, the requirement is very ambiguous, and sometimes the requirement can change. For example, maybe to this week, your manager think about, oh, I want to improve customer experience. I want to have more clicks. So maybe next week your company has some sales drops, and then your team want to improve revenue, and that might change. If you're building a machine learning model, that might change your like objective function, or if you're design experiment, that might change your metrics, right? So when you work on a project, always communicate with your manager. What are the most important thing? What is the problem you're trying to solve? If you just okay, I have this project, I work on it for a month without talking to anyone, and when you deliver the project, maybe it's not important anymore, or maybe it's not what it wanted. So again, because in school, every project, homework is so clearly outlined, there's very little confusion, and you can talk to your friends if you don't understand something, right? But in workspace, not every problem is clearly put out there, and everybody is coming from a different background. So even you're talking about the same thing, there can be a lot of misunderstanding. So always explain how you perceive this problem to your manager to make sure you understand the problem correctly. Again, in the beginning, when I realized, oh, sometimes we are thinking about different things and try to do this, that might make me sound, I feel stupid. I have to repeat what they say in my language. But then I realized my manager actually appreciate that. And also when I repeat the requirement, how I understand this problem, why it is important. Sometimes I also find, there's a lot of different understanding, and I'm glad we caught those discrepancies in the beginning instead of, in the end. Another thing is, in school, you don't just show your draft homework to a professor or your TA, right? You just show them very end. But at work, I suggest you, whenever you have an idea how you want to solve the problem, show that to your manager. Again, it's not going to be pretty. Maybe even your code is messy. It's totally fine. Show that to them to make sure whether it's in the right direction. And this is so important, because if this is not something what it wants, again, it's going to waste you a lot of time in the end. So how do you do a great project? You do great work not by just isolate yourself, spend a lot of effort. You do great work by iterate, right? Your first iteration, your draft might look pretty bad, but if you're in a good direction, at least you have a good foundation to keep improve it by getting the feedback from a manager or other senior people on your team, or even from your customer. And then a great work is achieved by those small iterations, and every iteration is from a sometimes a pretty crappy model, and in the end, say after you have 10 iterations, those type of back and forth, you will have a really good product, and then that's the product your company actually, your manager actually wants. So always get feedback early. So after I talk about this, right, it's hard to get data sometimes, and you might not always get supported from other team. Sometimes data is dirty. You have to clean it, build pipelines. And as a scientist, we learn those models in school. We didn't expect we have to spend a lot of time to do. Sometimes we need to do a little bit data engineering work sometimes. And that can be very frustrating sometimes. And people, I think some people leave data science job because of this type of frustration. So do you, does it mean it's not fun to do to be a data scientist? Well, the answer is it depends on, what you're interested in, right? If you're just say, oh, I just want to do models, I don't want to deal with, getting the data, then maybe you should be a research scientist, or maybe you can be a researcher or a professor. But if you are more interested in solving a problem, but also, of course, we're all interested in building models and theory, but you get a fulfillment from solving the problem from the beginning to the end, then this job, the data scientist, is still a good career for you. So data scientist, I think, it's also, I don't think data science is well summarized the responsibilities for this job. I would say you are essentially, like I said, the most important thing is solving the problem, right? You are a problem solver. But instead of engineers solve problem by building softwares, tools, or like if you're building a bridge, your tools are the bricks, and you're a data scientist, you're this type of problem solver, your tools are the data and the models. So if you're still find the problem solving exciting, then I would still encourage you to look past those struggles and become a data scientist. So the last part is, well, second to last is, how do you prepare interviews or transition your career? So I don't have enough time to go into a lot of technical details, and sometimes people ask me on LinkedIn, how do you, what should I study? Again, it's, I would say, if you, like I said, what's the most important thing as a data scientist? Problem solving skills, right? And if you can't even solve this problem about what skills you want to learn, and you ask some random people on LinkedIn without doing research, maybe you're not ready to be a data scientist yet. You need to do research on your own. But like what I said, first, you need to understand what type of data scientist you want to be, right? And then, because every type of data scientist requires different type of skills. Do you want to be a specialist? Do you want to be a generalist? And do you have a degree, PhD degree? What type of background you have? So you need to first think about it on your own to understand your own background, and then map that to the job postings. And what I always suggest is, how do you find the right skill to study? If you ask somebody, if you even ask a data scientist, this data scientist might be in a very specific field, and they might not give you the best advice. So what I suggest is, you, just like what I did, you go to LinkedIn or Indeed, whatever job site, just search for the data scientist job, and then with the type of data scientist in mind, and then you just do some research on that. Look at 10 20 jobs and then see what are the common word they use. Because for, again, using the example of a product analytics, A/B testing, you constantly see experiment design, product, metrics, and SQL. And then you know those are the things you're going to learn. So job postings are the best place for you to learn, for you to decide what you want to learn, how to prepare. And there are various sites where people share their interview experience. Some people post things on Glassdoor or even, excuse me, or even Reddit. You see some people's interview experience. But again, you need to know other people's experience can be very, very biased. A lot of people would complain about the interview experience because if you get a job, you don't usually post online, hey, I got a job, it's great, my interview is so great. Most people just go there to complain about things. So don't get frustrated. And then also, if you want to ask somebody for the experience, make sure this person have the same background as the job like you're looking for. And also, there is like no good or bad type of data scientist. It all depends on your background and your interest. Some people say, what type of data science should I be? I don't know. It depends on you, what you're interested in, right? Someone just shared something on the chat to say the word.net can quickly determine common keywords from Sylvia. Thanks for sharing. I haven't used that. But you guys can check it out. So the second thing is you will, I always advise people to apply. And if you follow my recent LinkedIn post, I mentioned something is analogy, right? You don't start to date people the moment you decided to get married. That's too late. Same thing. You don't just start to apply for jobs when you want to have a job, especially when you don't know what you want, whether you're a good fit. Some people send me their resume, ask me, oh, am I a good fit for the job? Again, I really want to help you, but I don't know. You need to ask, you need to apply. The only way to find out whether you're a good fit is to apply. But I understand why we don't want to apply. First of all, it's a lot of work. You have to change your resume, and it is work, right? And then second, we're afraid of the feeling of being rejected. We know if we're not ready, it kind of hurt our ego. But if you think from the other side, there's nothing really hurting you. Even if you get a rejection, then that's the feedback from the real world that maybe your resume isn't good enough, or maybe you haven't learned enough to get this job. And then just use interview. So when you are learning, when you're slowly finding your interest, don't think about interview as something once for all. Or you apply for 5 jobs, you get hired. Think of interview as a process of purely getting feedback. Just assume that you get rejected, so what, right? You don't get hurt. But again, don't apply for your dream job, because some big companies, I know, at least I think for Facebook, if you failed or if you did really poor, they might freeze your resume. So you can test some small medium company just to see, talk to recruiters, or even to see what questions they're asking, right? Usually they would just ask you to introduce yourself, and maybe you didn't even prepare a good introduction on your past project, and then they will ask your previous experience. Maybe those are the things you didn't really prepare. You are only focusing on the technical skills. So there are a lot of things about interviews. You only learn when you actually have interviews. So I encourage you to interview early. And also some people will get nervous, and those feelings, those experiences will never go away unless you practice. So yeah, just accept that you might get rejected, and then think of it as a way to help you succeed, and then have a type of positive mindset. And some people will see on the job postings, they want you to have say 3-5 years experience, and then that can be quite intimidating. So what I suggest is, again, everybody's experience is different. So if you are a PhD student or a master's student, although you don't have industry experience, but if your research or your coursework is very close to this job post, then you might have more experience than other type of data scientists who never worked on this field. And you can think of your research in grad school, in your PhD, or maybe even a college, some type of course project as your experience. So I would say, as long as you finish a project from the beginning to very end, from data collection to in the end evaluating the model, making decisions, you can consider those as experience. Now I'm not suggesting we should brag about experience and never lie about experience, but sometimes we need to give ourselves a little bit more credit when we think about experiences. Uh, and I think even my first job asked for maybe 2 to 5 years of experience, because they just want to put it out there, because why not, to have someone more experienced. And then I had the master, and then my interview was good, so I was hired. So from the hindsight, if I get intimidated by that, and I might not have the opportunity to get a job. But if something says, oh, I have experience on lead a large project, or 5 to 10 year experience, then maybe it's not worth it to apply. But you never know. If that's your dream job, you can try it. And if you just started to interview for data science, like I said in the beginning, it's a very broad field. You're probably not going to be able to know everything. And again, the hiring manager, if you think about what managers want, they want to hire this person to solve a specific type of problem on their team. So they're looking for this person have a set of skills. So they're not looking for someone who knows everything. So it's okay, you don't know everything, and then but you have to know the foundational skills. For example, if you are a data science, you want to interview for a data science generalist type of role, and then you need to know, at least you need to know some regression, right? How to evaluate a model. I'm just giving an example. Again, I strongly suggest everyone to do your own research to find out what is important for a specific job. And then if you don't know everything, it's very easy for interviewer to see whether you're lying. I have experience, if someone don't know what I'm talking about, or don't know, they just start to talk about something else, and then it's obvious, other people can tell. If you don't know it, just say you don't have experience on that, and then say but you can learn something. And but if your interviewer have seen you demonstrated good foundational knowledge and think you can learn, then they might still hire you. Just be honest. And then if you don't understand, ask them to repeat a question, and it's also totally normal. And if you have a LinkedIn account, I strongly encourage you to have a LinkedIn account. I found my first job and also my second job in Amazon from LinkedIn, because recruiters reach out to me. So if you're, I think the Amazon recruiter found me because my first job title was business intelligence data analyst, and they were looking for a business intelligence engineer. So the title matches. I think it's as important at that time. So I also, put down some keywords of the project you're currently working on, and then don't just put down a title, and then it will be easier for them to find you. And also, if you found some recruiters posting a job, and if you want to message them, it's also easier for them to look at your experiences if you have something there, right? And also, I think right now LinkedIn support the function that you can upload your resume there, so it's also easier for people to find. I would say, if you want to reach out to people on LinkedIn, reach out to the people who actually post jobs, or especially recruiters. A lot of people send a resume to me, but I'm not hiring anybody. I'm a data scientist on the team. It's not helpful to send a resume to me. Network with recruiters, and also if you like. I would say I would encourage everybody to try and think big, but it's also not very likely for someone don't know you to recommend you, right? I wouldn't say you definitely shouldn't do that, but at least for me, if I don't know you professionally, I would feel that's not very responsible for me, and also for you, and also for my company if I refer somebody I don't even know. So talking to recruiters are more productive in this way. And if you want to transition your career, I think someone also asked about something from Mo, asked something about switching career to data scientist. Sorry, I'm just gonna read the chat a little bit. Yeah. So if your team have data scientists, or if your company have data scientists, it's easier for you to do the transition within your company. But if it's very different, maybe you need to look outside. You need to go back to school or get a certificate, or do some type of internship. That's a little bit I think you might need to take more time if you're come from a completely different career. So here what I'm talking about is I believe most of you here are already in school, or doing some type of data science role. So instead of looking outside, the best way to do it is within your team. Because first of all, your manager already trusts you. So this is have a condition, right? You have to perform well on your current role. And if your company has some data, I'm sure a lot of companies now value data science more and more. They always have something on the backlog, some type of analysis they want to do, but never got a chance to take a look. And here you can propose to your manager to see if your managers have something they want to look at. Again, this is tied back to the previous point when I mentioned the business value, right? So if you want to transition to a different career, although your being a data scientist can add value to your company, but during the transition phase, you need help from your team, from your manager, or from your company. And it's easier that you're also providing value to them. So try to see if there's any low-hanging fruit data science related project that can add business value that's tied to the goal of your team. And then take on those projects as side project while you're working on your current role. And then make sure you finish this project, and then have some type of models or analysis that actually improve the processes or the business, so actually provide value. And then at that time you can talk to your manager to see if your manager can help you transition from, say, an engineer or a business analyst to a data scientist. And if you have it's better if your team already have other data scientists. You can see if you can help them with some project. Again, start from adding value. Maybe they won't let you to do those fun part like modeling with them. You can just start with say, hey, can I help you build some pipeline? Can I help you do some exploratory data analysis, or do some type of industry research? And once you're familiar with the project, later on you can see whether you can learn about some modeling from them, because you always want to try different. There in data science project, there are always so many things to try. And then once you're familiar with the project, and then you earn trust from your coworkers, and maybe you can also get to learn some modeling a little bit, and then it's good you collaborate with the data scientists on your team, and then if you need to transition to a data science job role, they can also voucher for you. They can prove that you already have good data science knowledge and then actually works on a project. And then another important thing is to don't just secretly work on the project. Always transparent and communicate with a manager. I have mentored some other analysts working Amazon, and I think in the beginning they are maybe they're scared. They don't know whether their manager will approve it or not. You never know. A lot of them, after they talk to me, they talk to their manager. They most of the people I talk to actually got support from their manager, and then to take on some pet projects. Well, this doesn't guarantee they will eventually switch you to a data science role, but at least you will have experience. So this is something you should do if you want to transition from a different role to a data center. Look inward and then get support from a manager and start with a project that will add value to your team. The last one, if you're still here, the bonus is communication and leadership skills. Why I talk about this in the data science meetup, like I mentioned before, right? Data scientists, you are a problem solver, and it's very rare that you have the data ready and then you just present your result to other science people. You can work on the team where other people don't speak your data science language. Going back to the example where I mentioned, right, my first presentation to marketing people, if you just think about what they're interested in, what problem they're trying to solve, and sometimes thinking is not going to help you, right? Because you didn't know marketing. Even if you do some research on marketing, it's not going to be the same for them. And so how do you learn how to speak their language? It's very simple. Just ask them. It's very important when you start working. The communication doesn't always to happen in the actual time you schedule the meeting. If you want to have effective meeting, it starts before the meeting. So for example, you can search who are the key stakeholders in this meeting. And for example, you see your data science project is going to a product manager, and this product manager is going to going to own this entire product, right? Then before the meeting, you need to show your results or your presentation to this product manager to make sure this is what they want. And if they have questions, you can explain, or maybe they're confused. Great, that means you get some feedback and you can change your presentation or your documents earlier. So make sure you, if you have a meeting, just search a little bit to see who's going to be in the meeting, and then communicate with the key players in the meeting before you actually go into the meeting, and make sure you get some feedback. Because if they already tell you what they don't like about your presentation, and then you fix them, and it's more likely for them to be on board when you present, right? And instead of you get blindsided by their question and then you don't even you're not even prepared. And another thing is sometimes if you work with a different team, for example, your team think this is a great data science project, the engineering team should launch it. But engineering team, again, they might have their own ideas, right? It doesn't mean, again, there's no right and wrong. I have seen data scientists sometimes can be very defensive. Sometimes in the meetings, it becomes a fight. And it's not very helpful in terms of finishing a project, right? I would say instead of feeling defensive, because again, like we all work very hard on a project, especially when we think about how much data we have collected, the pipeline they're building. If they have pushback, try to understand why they are pushing back. Is it because it's not their priority, it's because they don't have enough people to help. Again, if there's something your manager can help you resolve this issue. And if you're in a meeting, you're the only person invited to the meeting, and then the other team's manager or senior principal engineer in the meeting, and you might get pushed back. And what do? You no matter how much you prepare, if you're a junior data scientist, it's very hard for you to convince them, right? I don't mean you can't, but it will be hard. So at that time, you need to have some sponsors from your team. You can just ask your manager, hey, well, they invited their senior manager to the meeting, and then I'm the only one on the team. I believe this is an important project. I want to get this launched. Can you come to the meeting with me? Or there's a senior data scientist, brief them about this project, say, I need you to come to the meeting to support me. Of course, you don't want to blind support. The people you invite from your team also need to understand your model, your approach. And if they disagree, you need to also resolve it offline, because you don't want them to disagree, your people on your team to disagree with them during the meeting. But it still happens. Sometimes your people from your team might disagree with you on the meeting. Just don't feel defensive. Don't feel like, oh, are they trying to, undermine me? No, because sometimes you only think of some problem on a certain time. Maybe they just didn't think of that before. Just again, just don't get combative or defensive or easily offended. Look at the problem from a position where you want to solve the problem, do great work, instead of turning everything into an attack. It's not always about you, right? It's about the problem you're trying to solve. It's about the value you add to the team and the product. And the second one, influence. I talked about, if you don't have a lot of influence, you can leverage your manager's influence, other people's influence. And also influence comes from also, if you prepare for a presentation, you think this model is important, the influence comes from how well this is aligned with their goal. And if your product is also important for their team, maybe it's easier for you to influence their decisions, right? Can you find a angle where you can have a win-win situation? If they help you, the other team help you, the other team support you, right? How do you leverage those resources? And if you feel you don't know enough about the other team, one thing is to communicate with your manager and also meet with them one-on-one before to get their perspective before the meeting. And the third one is ownership. Before I talk about ownership, in my introduction, we mentioned I have a patent on A/B testing, and I actually work on the patent the first year when I started in Amazon. How did that happen? So I wasn't the main contributor for the patent, but my senior data scientist on that team, she need help with the work. And this piece of work is not related to something I was originally assigned. So I could totally say, oh, I don't want to do that because it's outside of my scope. I can, just push back. But because I just started, I think when you started, it's hard to know what is important, what is not important, when to say yes, when to say no. Maybe I would suggest try to say more yes when you just started. I know a lot of people saying, oh, if you say too much yes, that could be a lot of work, or you will get lost in priorities. Again, your manager can help you prioritize, but if you have some bandwidth, you can say yes more, because you don't know what this project will turn into. So I did that because I want to help the senior scientist on her project, and then in the end, I work with her, and this becomes a patent. And then because I contributed a lot in this project, and then everybody who worked on that were added to the patent. So, and also it can come in another example would be, we have a sister team, and I found there's some issue in how they collect data, right? There's always going to be a lot of issue in data collection. And so what I can do is I can just say, hey, there's an issue in your data. And then I just leave it to them. But you need to also know that sometimes other people might not take your feedback that seriously. They have their work to do. They don't care whether their data quality issue affects your model. So what I did was, I believe the data quality issue was very important to fix. So I worked with them closely. I said, okay, like if you don't have time, I can have time. I can work on this. I can help you figure out. Again, I'm not an engineer on that team. In the end, I still need their help to implement the change of the bug I found, but I can be a investigator to find where is that bug. Is this the data science work you learn in school? Is this some type of fancy modeling? No, it's not. I was simply an investigator. Again, this ties back to the importance of problem solving, because this is important to ensure high data quality. So I help them solve the problem, and because it's not their high priority, but a bug is still a bug. And then the other team was very appreciate my work there, and then they also gave great feedback to my manager. So a lot of people, when they think about project, they just want to do their own thing. They get annoyed when other people ask them for help. I sometimes feel that way too. Like I have my own project, and who's gonna help me? And then this is going to be up to you to find a balance between completing your own priorities, not get burned out, but also if you think about your entire work as a portfolio, right? If you are investment portfolio, what we want to do, we want to allocate asset, we want to diversify, we want to mitigate the risk, right? Because sometimes one data science project it's possible that it won't yield into any results. It's totally possible. Maybe some other project you invested in actually have good results. So when you have time, help other people, but not like I was lucky, right? Those two projects I helped had good results, have good helped my career. But there are also other projects that helped, it didn't do anything for me. And if you always think about the results, what does it do for you? In the end, you might not feel fulfilled. And also other people on your team, because if you do this, other people might see you as always, oh, just being selfish and thinking about your own success. So just be generous and helping other people, and maybe someday other people are more willing to help you as well. So it's hard again to find a balance between work and the life. And at the work, there's we don't always talk about like care about your coworkers or something, but if you work with them with a sense of, you care about your coworkers project, you genuinely want to help, then you will be seen as a very good collaborator on your team, and then maybe other people want to collaborate with you in the future. So being a team player, have ownership, and be generous whenever you're capable of. So yeah, that's all I would like to share today. And I'm going to ask some questions, but before I do that, because I get a lot of messages from LinkedIn want me to be their mentor. It's very hard for me to do something one-on-one, but I think this is something I made so many mistakes, and I would love to help other people to learn about those things, like those anecdotes I shared, and I like working with people and helping other people to succeed. I also write LinkedIn. So if you search my name, Daliana Liu, data scientist on LinkedIn, you'll find me. You can follow me or connect with me. And I also have this website, dalianaliu.org. If you go in there, you can find a signing link. So if you enter your email, I will try to spend more time to have more this type of knowledge share about career, either soft skills or technical skills with you. Because data science is a very fast moving area. I think there's always so many things to share. There's so many things haven't been talked about. So if you sign up, and I will be sure to be in touch with you. And also, I want to write articles to talk about my struggles. There may be something kind of personal I don't want to share on LinkedIn, but I think if we're connected on email, it's easier for me to share those examples from storytelling. So if you want to get in touch with me offline, please sign up on dalianaliu.org. And do we have some time for Q&A? I can answer some questions.
Yes, we can continue with questions.
Okay. Yeah, I saw some. I saw a lot of questions here, trying to see what are the important ones I can answer. I think this one might be representative for someone without any programming background. What is the best way to become a data scientist? This is a great question. When I was in grad school, I learned R, but the way I use R was just one line of code for regression. I didn't learn programming. So, but I was able to just work on some simple models. The way I learned was from work, because my first job, the very, very basic R is not very functional programming that I learned was sufficient. So you can, if you want to be a data scientist generalist, you can start from a job where they have low requirement for programming and learn it on the job. So usually, or if you if you are, again, I don't know this person's background, but if you have background in statistics, A/B testing, maybe you can start from the path of product analytics type of data scientist, but you still need to learn some SQL. SQL is fairly easy to learn. If you sign up on Lead Code, probably a lot of you have heard of it. They have a SQL section as well. They have some sample interview question answers there you can learn. They have beginner, intermediate, and hard. So maybe this is the type of data scientist you want to start with. And also, if you're already a data scientist, but you want to learn more data programming, if you want to learn a new language or model, the best way to learn is to actually use it. So I was using R for the first 2 years of my career, and then I realized a lot of tutorials are in Python. And then there are some online tutorials. There are so many tutorials. There are so many good tutorials. Anyone you find should work. Just commit to that and finish that. But the most important thing to use it. So I made a decision. There's a new project, and then I know it's not urgent. So I told my manager, I'm just gonna switch R from Python in this project. And it was a bit risky. But I also give myself this pressure. That means I have to learn Python to finish this project, right? And I already told the manager there's no turning back. And also I know, I still know how to use R, and if Python doesn't work, I can always switch back. So of course I spend a lot of more time on this project because I'm new to Python. But eventually I learned Python. Am I on the level of software developer? No. Do I write that level of code, but it's good enough, again, to solve a problem, to bring value to my team, to build the model that I want to build. So if you want to learn, find a course tutorial, but don't dwell on it for too long. Find a project, either a Kaggle project or something, a fun project. You have to use it in order to learn it. Can I target machine learning data scientists as an entry-level computer science grad? Yes, I think you can. You need to, again, take some courses on machine learning, I think it might be a learning curve for you to understand probability, the math part, but it's learnable. Actually, I find a lot of my coworkers, some very great data scientists, a lot of them coming from computer science background, because like I mentioned, if you're on the team, not every team, but those type of team that focus on deployment, model deployment, production, they will very favor data scientists with computer science background. And then when you apply for jobs, you can just be transparent and mention, oh, I'm new, I learned about your computer science background. And then there are teams, if they believe you already understand the foundation of statistics, machine learning, and of course, you also need to show computer science, and then they might want to bring you on board. So focus on the foundation knowledge of machine learning. Make sure you understand those models, Google those common interview questions, and then the computer science will be a strength for those teams that focus on production. So yeah, you can totally do that. How difficult it is for someone to get into AI who doesn't have a strong math and stats background, but has a program background? It's the same question. So if you, like already answered, if you already if you're already a programmer or engineer on the team, like what I said before, you want to transition, learn, and also find a project on the other team or from the data science on your team to see if you can collaborate and get experience. It doesn't matter how much you learn. If you never get experience, it's hard for you to transition or put it on your resume. How do you keep up with new techniques and development, given that you would strive towards simplicity and direct business impact in daily work? This is a good question. So I would say it's not always simplicity, right? So it just really depends on solving the problems. The new techniques, there's so many new techniques. If you're catching every new shiny thing, that's going to be very, very exhausting. So focusing on the project you are working on right now, you always learn something new on the project, focusing on the problem you're trying to solve now, and also focusing on your own interest. So again, think about the 3 circles I mentioned: your interest, the technical depth, and the impact. And there's no one source you can do. So if you think, okay, I'm going to work on this project, help with agriculture, and then maybe use machine learning, you just Google it and see what's out there and learn right there. And then just start with something can immediately solve the problem, but this thing doesn't have to be state of the art. Maybe a simple regression model can solve it. So I would say, again, I would emphasize having a great foundation knowledge, because if you are solid in your foundation, it's very fast for you to learn the state of art new method. So a lot of times the new things are kind of overrated. Can you give an example of what you mean by building pipelines? Yes, building pipelines meaning, for example, your engineering team has a lot of transactional data, right? I'm talking about this, this sounds specific, but like you might experience if you work in data science. But those transactional data are in like raw logs in JSON files, and those are not well parsed. And then your engineers maybe store those data somewhere in their database. But in order for you to consume them, you need to put them in your database. So when I say pipeline, it's just a very generic term. It doesn't mean you have to use a certain tool. It just means you get data from one place from the other. And this pipeline can vary from project to project. So sometimes you need to use some Python, sometimes SQL, and also sometimes you can ask the other team, like if this has a lot of business impact, can they build this pipeline for you? Again, like discuss with your manager to see what is important and whether you can leverage some type of engineering effort to have the pipelines built for you, and then you let them know what is the requirement. As a fresher, how can I prepare and crack my data science interview? I'll just repeat what I mentioned again and summarize. First, know what kind of data science do you want to be? And second, go to research 10 job postings and find keywords. And third, get feedback by start interviewing or talk to recruiters. And also, if you have friends working the similar field, asking them for some advice. But again, I would say rely more on the feedback from interview, from recruiters than other people who have a data science title, because they can be very different. Karen asks, what's my day-to-day look like as a data scientist? Do I have a list of priorities to be done every day? Do you check off your list when I feel like I'm accomplished something today? Good question. Yeah, I can talk a little bit about my day-to-day. Every day is different. Now I work with you as a data scientist. You always have type of customers. So sometimes your customer is your internal product team. Sometimes, like right now, my customers are actually AWS external customers. So you have some meetings to understand the requirement or their feedback for the model. And then some other time in the beginning of the project, I will start to research do some model exploration, research to think about what type of method I might want to use and learn a little bit. And then, like simultaneously, I will start to think, okay, where should I get data? What if the data quality is bad? If I don't have enough data, maybe I need to get some proxy. So you really spend a lot of time thinking about what type of data you need to use to solve the problems. And then, if you work for a company, you have one-on-one with your managers, you have the team events, and sometimes you also get pulled into other meetings that they want to get your feedback for their project. So you have different type of meetings, and then your day-to-day really depends on the stage of your project. In the beginning, maybe more meetings, more kind of data cleaning, data processing work, and then in the middle, more research, build model, and then in the end, how do you evaluate a model? How do you stress test the model? How do you put it into production? So yeah, it really depends on the stage of the work. Is there audio recording of this sharing? Yeah, there is audio recording. I think the organizer will post it on their website, their YouTube channel. Do we have more time? Just try to be mindful. Are there other agenda we should touch?
We can continue.
Okay. Yeah, thanks for your patience. I apologize, I can't get to every other question because some of them just seem too specific. I will find one when I see they just occur a lot. What kind of degree do you need to become a machine learning researcher? Do they prefer computer science majors? If you're talking about researcher, if you're a researcher, I think there are a few routes. I have seen people study physics or other type of engineering where they programming heavily. So if you think about thinking about what you want to achieve, right? Machine learning researcher, you need to find what are the requirements for the machine learning researchers. Some of the job title is called machine learning scientist, or some company kind of leave out the machine learning part in the job title is called research scientists, but then they will specify they want you to know machine learning. And then some other company, for example, Amazon, is called applied scientist. So you need to kind of think back. Usually this type of researcher will require a master or computer science degree. But if you, I know some people who have degrees in, say, biology, chemistry, but they use the machine learning heavily during their research, and can program efficiently, then that's sufficient too. So it's not about, I think right now in the workplace, it's degrees that still matters, but it's less about degree, but it's more about what skills you have. But I would say if you're looking at the researcher title, you need a master degree at least. Do you find that it's more difficult to get in the field from data science bootcamp than to have a master or a PhD? This one is a good question. I didn't go to a data science bootcamp, so I might not be the best person to answer this, but I have friends who've been to the bootcamp. Some bootcamps seem to be pretty good at teaching them very practical skills. I would say some skills are even more practical than what I have learned with a master's degree. Is my master's degree useless? I don't think it's useless. It's just there's a mismatch there, and also have a title there. It's easier for a recruiter to trust you in a way. But if you find a very good bootcamp, especially those help you with interviews, help you with the actual create a data science portfolio, I don't think it's bad. At the end of the day, it depends on what did you learn. So you need to, if you want to get in a data science bootcamp, just make sure they are teaching something useful that's related to the type of data science job you want to get. Arvind asked something about software developer to machine learning. It seems like this is a lot of people have this question. I think I have answered that. Start with the basic, learn foundational machine learning, learning the classical machine learning algorithm. Start from regression, really understand the cost functions, how to evaluate the model, and then move to the deep learning. There's no what is the best way? It really depends on, again, on if you can switch on your team within your company, that's the easiest. Build a machine learning model for your team, right? And if there's no opportunity on your team, maybe you can do some side project to learn, get some online certificate, and then look for a job elsewhere. Or start with when you can also become an engineer on another team that has data scientists. So you still go in there as a as a developer, right? But this is what you already know, and you bring value to the team. But on this new team, there are other data scientists you can work with. So that's what you can do. So just have a patience. Be patient when you want to change career. Always easier to start with something you're good at, and then you can find a team with mixed talent, and then go from there. Is it true that we need to have knowledge other than programming an area where we're getting our data from? If so, how much of this knowledge? Some basic, enough, or advanced? This is a good question. I think it depends again on the team you're on. There are some teams, if you're on a large company, they are machine learning, they're like data engineers, right? And the data engineer's job is to help you getting the data building pipeline. So maybe you don't have to do it on your own all the time. You might just need to build some SQL, do some light data pipeline building. It really depends on the team. So when you're interviewing, you can also see based on the interview, you can also figure out what's the structure of the team. If they ask you a lot about data pipeline, then you know you need to have that type of skill. But I would say I wouldn't really prioritize that skill when you prepare for interviews. That's very important sometimes, but it's something you can learn on the job. And also every company's data pipeline is very different. So if you know basic SQL, you can learn the system on the job. And also during the interview, and also when you read the job description, right? If you constantly see things like building pipeline, SQL, but very little mention of modeling. But if you're really interested in modeling and analytics, maybe that's not something you're interested in. Again, I'm not saying those jobs are bad. It's just find what you're interested in and then learn it. So when I just started in my first job and second job, I just know very little SQL, but through my work, I learned how to build pipelines. Again, you're not on your own. You have people to help you, developers, and then you build the pipeline. And this pipeline doesn't have to be perfect. The purpose is just to get the data so you can build a model. So you don't need to be so stressful about that. And average Camila's question, if I'm an industrial engineer, how much time would it take for me to be somewhat ready to be applied for these jobs? I mean, to learn most of this stuff. There's no, yeah, you'll probably hear me say this a lot. There's no, it depends, right? It depends on your background. It depends on what type of data science you want to get. So I would say industrial engineer, you're already engineer. I don't know, maybe you know some programming skills. So you can just see with your current skill, what is the minimal, what is the type of data science that requires the minimal new skills based on your current skill, right? That could be a low hanging fruit. And also another way for you to do this, if you're very familiar with your current industrial engineer, I don't know what industry are you in. You can look for some jobs that's already in your industry, require both industrial engineering skill and analytical skills. So you can do a slow transition, again, using your strengths, using what you're already good at, and then you can slowly, not slowly, but sometimes you probably need to learn fast, but then you can slowly get yourself ready to be a data scientist or data analyst. How important it is to have GitHub account and post your project there, so that I can pretty much store measurement garbage if I don't have any code to post it online, GitHub. Good question. Yeah, a lot of people saying, oh, should I have a website, a portfolio, GitHub? I would say those things helps, but those are not a must. Because if it is a must, they will put it in the job requirement. And I did hear people say, oh, I have a really good GitHub account and some recruiters found me. So again, it's just really nice if you have that, but if you don't, it's okay if you don't. I don't have a GitHub. I started my blog after I started my job, and then I don't think anybody found me on LinkedIn to try to hire me because they found my blog. So don't worry about it if you don't have it. But if you have the time, just want to share your knowledge, there's no nothing bad about it. It's just if you have limited time, you don't need to put it as a priority. What type of data science is the most required nowadays? What most required? This is a hard question. I don't think there is one most question, right? It's really depends on what problems those companies trying to solve. I've seen a lot of A/B testing type of jobs, and also a lot of machine learning AI. But I would say those type of general data scientists are still very popular among maybe medium-sized company or a team where they support products and engineerings. And if you are on the research, a team where just a lot of researchers, that's a different type of story. I don't think there will always be like the most required type of data science. I would say in the future, probably it's going to be easier for people to apply machine learning models because you can easily use transfer learning. You can just download a model and run it, train it on your own data set, right? And maybe in the future, they're going to be auto ML. Eventually, I don't know, maybe there will be something like Excel, you can drag and drop something. So it will be easier to implement a model, but there's always going to be the skill to decide whether this model is good or bad. The model evaluation, the critical thinking skill, how do you use your data science model to decide whether they would be good for the business. So you're always going to have that type of skills. Any advice if you want to grow into a decision scientist role eventually, Michael? Oh, audio is gone. Can you hear me?
Yes, we can hear you.
Oh, okay. Decision scientist, I think this is a fairly new role. I'm not super familiar with that, but based on my understanding, you usually starts from a data science, from a A/B testing experience. A lot of decision comes from, I think now when people talk about decisions, like the job I shared earlier, the one about Lyft, they talk about decision making, right? Because after you run A/B testing, how do you make decisions? So I think something you definitely need to learn is A/B testing, and also a lot of things about false positive, false negative. How do you, because most of the time A/B testing doesn't have significant results. So how do you find a signal from the noise? I think you also need to understand the probability distribution pretty well, understand sample survey, maybe a little bit causal inference, right? Is this random or is this a true signal? But this is my assumption. I encourage you to do your research, look at the job titles. Is it better to learn Spark SQL than Spark? Depends on what you want to do. Spark SQL is Spark SQL. I used Spark SQL before. It's very similar to SQL. But if you learn the general context of Spark, you can learn SQL. Again, like a lot of depends on the job requirement. Learn the most essential skill. If you're looking for a particular job that only use Spark, you can start from there. But if you already know Spark, you can process data using Spark, using PySpark, Spark SQL. Shouldn't be a big blocker. I answered this question is also, I want to talk about a broader domain, go into a higher level. Sometimes we're like, oh, should I learn NLP, computer vision? Should I do this and that? Sometimes we don't need to kind of limit ourselves into those details. Think about the foundation knowledge. Ask yourself whenever you don't know what to learn, ask yourself, what is this one thing I can learn that will make other 10 things easier to learn, right? So if you learn the basic of machine learning, deep learning, you can maybe pick it up fairly quickly. And if you learn SQL, you can learn Spark SQL quickly. So just find out the most foundational things you must learn. what do we need to have knowledge of big data for a data science job? So yeah, even till today, I still don't quite understand what exactly is big data. It's just a lot of data. I think people talk about big data usually means how do you process a lot of data. I think you need to, if you know Python, I think you should be fine unless the job is very specific. If the team use Spark, maybe you need to learn Spark, for example. But what I want to say is just don't pick a tool or a subject that's very time consuming just because you saw something somewhere. Think about allocate your time intelligently based on what's really important for you. And maybe in the future you need to train your machine learning model on multiple CPUs or GPUs, and that time you can learn multi-processing. But if you're just starting, maybe that's not, it's definitely important, but it's not the most important thing for you right now. Is there a recording? Yes, there's a recording. Yes, anything doesn't fit into Excel. That's Michael mentioned the big data is anything doesn't fit into Excel. Yeah, it's just there's a lot of kind of fuzzy things when you see news articles talk about big data, data science. A lot of things is just really not very reliable from the source. You don't need to. Also, sometimes maybe some people want to market something, they would say, oh, this is the most important thing you should learn. I would say just don't get easily distracted by the new shiny things. It's focusing on of course you need to keep an eye on what things are the new stuff, but if you're thinking about your career, look at the job descriptions. If you already have a job, think about, ask your manager what type of models problem you're trying to solve, and learn from there. But if you have time, just always allocate some time to learn something new, and you never know what day you're going to use it. I think that's pretty much I have for the questions. Any other specific things you're interested in?
I think this is pretty much it.
Okay.
Thank you, Daliana, for this awesome presentation. And we would like to thank everyone who had became a part of today's online webinar. As Magnimind Academy, we will continue organizing these similar events in the future. You're always welcome to join our events. And having said that, I am finishing today's webinar and thanking Daliana Liu for her participation. You're on mute.
Oh, I was just gonna say thank you, and thanks everybody for participating, asking questions. Yeah, I'm glad to be here, and I enjoyed sharing this with you. And if you want to find me later, you can sign up here, and I would look forward to talk to you again. See you.
Yes, and for the ones who want to watch the record of this webinar, you can go and subscribe our YouTube channel, Magnimind Academy, and find all of our recordings there. And thank you for all. Have a nice day.